The second type of object, second and third type of object in Rhino are surfaces and polysurfaces. So that there is a surface. If you select it, you can see up here type of object it is a surface, and up here you can see one surface added to selection. This here, right, so this here, when I select it, it all selects together. So this is not a surface, this is a polysurface. Polysurface. One polysurface added to a selection. So the difference between a surface and a polysurface is that a polysurface is two or more surfaces that are joined together. So here you can see that this polysurface is made of two surfaces and they're joined together. You can tell they're joined together when you click on it. It selects it as one. So that's a surface, that's a surface, they're all surfaces. Select it all, 6 surfaces. Now when I select this one, again, that's a surface, that's a surface, still 6 surfaces. This one here, when I select it, it all selects together. That means it's a polysurface. All those surfaces are joined together to create a polysurface. So you can explode a polysurface into its individual surfaces with the explode command. So if I type in explode, select objects to explode, so that's exploded it. So now there are 2 surfaces. That's a surface and that's a surface. You can turn it into a polysurface by selecting them both and using the join command. So that's now 2 surfaces joined into one polysurface. So I can join all these into a polysurface and explode it into individual surfaces. So this here, it's a polysurface. So this is made up of 3 surfaces joined together. So one along here, one along the top, one along the bottom. I'll use the explode command. That's surface, surface, surface. I'll select it all together and join it. So now when I select it, it all selects as one. That's a polysurface now. So surfaces and polysurfaces, they have no thickness to them. They're infinitely thin. And surfaces and polysurfaces can be open or closed, just like curves can be open or closed. A closed polysurface means that it encloses a volume and it's airtight. So if I select this, it says that it's a closed polysurface. So that encloses a volume and that's airtight inside. Another name for a closed surface or a closed polysurface is a solid. That's why it's got the word solid there. A closed polysurface is hollow inside. Just because it's closed doesn't mean it fills up with anything. So this here, that's an open polysurface. It's obviously not closed. So if I create a sphere, I select that. So this is a closed surface. This isn't a polysurface. There isn't multiple surfaces joined together to create a polysurface. This is just the one surface that wraps around, and it's closed. So this also is a solid. So I'm just going to make a little hole in this. So when I select all these surfaces together and then join it, notice how it says it's a open polysurface. So sometimes if you're trying to create a closed polysurface and it's not creating a closed polysurface for some reason and you can't figure out why, there could be a little hole in it like that, and it can be difficult to find. So there is a command called show edges. So I type in show edges. So it's showing the naked edges in pink. So that's where it is there. So this is similar for creating a closed curve. Sometimes you can have trouble creating a closed curve. You can use these show ends, and I'll show you the ends on the curve. So this is similar. So once you see that, you can see where the hole is. So I will use the planar surface command to fill that in and then join it together. So now it's a closed polysurface. So surfaces can have a seam to them, just like curves have a seam. So that's where the seam is of the curve. So if I extrude that, extrude the curve, then if I go into the display properties, so that is the seam. Explode it. So this surface here has a seam. You can tell where the seam is by going into display and turning off the Izo curves. That's the seam. And you can snap to the seam. So I will create a sphere, and you can see where the seam is of that sphere. I'm going to turn off the Izo curves. So that's the seam of the sphere. And again, you can snap to it. So this here is a surface that's closed. So surfaces have a U and a V direction. All surfaces have it. I extrude this curve. So the U and the V direction can be demonstrated, or of a surface can be demonstrated by using the extract Izo Curve command. So if I type that command in, select surface for Izo Curve extraction. So this is extracting a curve on the surface in the U direction. So you can tell that along here, that's the U direction of the surface. So if I change the direction to V, that is the V direction of the surface. Let's create a sphere. See where the U and V direction is of a sphere. So extract Izo Curve. So that there is the V direction. Right, so this here is the U direction of the surface. So you'll notice that surfaces have lines on them. If I extrude this, see how there are these lines? So these lines are called Izo Curves. And they're basically there as for a number of reasons. One reason is they're there for a visual aid. And the Izo Curves run in the U and V direction. So this is only running in one direction. There's no Izo Curves running in the other. Here you can see the U and the V. So some of these curves that you can see, not only are they Izo Curves, but they may also be a seam. So if I select Surface Izo Curves and turn the Izo Curves off, that's the seam. And then when I turn the Izo Curves on, they're all the Izo Curves. Izo Curves are also important for selecting geometry. So you can see those Izo Curves in the U and the V direction. So if I explode this into individual surfaces, if I select here, it's going to select that surface. If I select here, it's going to select that surface. But if I select the Izo Curve of the surface behind it, it'll select that surface. So that's how Izo Curves, that's another reason for Izo Curves. They can be used for selecting geometry. Surfaces and polysurfaces, just like curves, can be planar or non-planar. So that there, that's obviously a planar surface. All these surfaces here are planar. I extrude this. So this surface here obviously isn't planar, so this is a non-planar surface. It's a three-dimensional surface, whereas this one here, that's just a two-dimensional surface. So surfaces are created by control points and degree of curvature, just like curves are. I create a curve. that one up. And if I copy this up there, then if I loft these three curves together, so when you select a curve in Rhino version 6, the control points will automatically turn on. But when you select a surface, the control points won't automatically turn on. So you can display the control points of a surface by using the points on command. So that just turned the control points on. So again, this surface here is a degree 3 surface. It was created from lofting degree 3 curves together, and it's non-planar, so that means it's going to be a degree 3 surface. And it works the same way curves are. So again, the same type of maths that's used to create a curve is used to create a surface, which is called NURBS. And again, a strength of this type of maths is its accuracy. Every point along this surface here is mathematically calculated, and it's extremely accurate at any point along this surface. So just like curves, you can move control points around. You can do that with surfaces as well. If I select a control point, turn my gumball on, if I move that point, it's going to move the surface. Again, a degree 3 surface will flow nice and smoothly. If this were a degree 2 surface, it wouldn't flow as smoothly. And if this was a degree 1, it would just be all flat and planar surface. This obviously isn't a degree 1 surface. So just like curves, you can rebuild a surface. So I just typed in the rebuild command, and it's got the point count. So in the U direction of this surface, currently there's 5 points, and in the V direction there's 11 points. So we can rebuild this, and then the degree is obviously 3. So let's change this to 25 control points in both the U and the V. Actually, I'll copy this like that, and then rebuild this one. So 10 in the U direction, 10 control points in the V. Then I'll go points on to display the points. So if I select these two surfaces and go points off, control points are now turned off. So see how there's a lot more Izo curves displaying in both the U and the V, where in this one there's only a lot of Izo curves running in one direction. That's because this was rebuilt with more. So if you select this surface and type in the what command, you can see it's a degree 3, and in the U direction there's 10 control points, in the V direction there's 10 control points. We go what? See, in the U direction there's only 5 control points, B direction is 11.